Welcome back here, section 3.4 or 3.3 video 4. We're now on example number 7. We want to take this expression that's just one log and we want to expand it out into multiple logs. So when I look at the argument of this expression, these guys are all multiplied together. So when I expand it, they're all going to be added. So I've got log 12 plus log x to the 5th plus log y to the negative 2. And that's because they're being multiplied together. I'm going to add them when I split them up. And then the second step is to take any exponent that I see and move it down the front. So this is really log 12 plus 5 log x minus 2 log y. All right, for b, my argument is being divided. So when I split it up, I'm going to subtract my log. So natural log of x squared minus the natural log of 4x plus 1. For this first natural log, I'm going to bring the 2 down and make it 2 natural log x. The second one, I'm going to do a little bit of work. I know 4x plus 1, like we just talked about in the last video, is 4x plus 1 to the 1/2 power. And then I can move that power down in front. So this is 2 natural log x minus 1/2 natural log 4x plus 1. Now be careful, a lot of students are like, okay, well now I've got them added, so I'm going to multiply them, and they do some weird stuff. No, we have no rules about adding of the argument in the log. So you stop here and don't keep going. For the u tries, then this would be log 13 of 6 plus, it's going to be log 13 of a cubed. I'm going to go ahead and bring that 3 in front. So 3 log, base 13 of a plus log base 13 of b. And again, bringing that 4 down in the step 4 log base 13 of c. For b, we're dividing, so we're going to subtract it. So that's natural log of 3y plus 2 minus natural log of 4 times the cube root of y. Now I've got a multiplication problem here. So this is natural log of 3y plus 2 minus natural log of 4 plus natural log of, this is y to be 1/3 power. So, right, the cube root only belongs to the y, so the 1/3 only goes with the y, not with the 4, because it was out front. But these guys are multiplied together, so I'm going to add them when I separate them. But don't forget, you've got that negative side that's going to be distributed to both of those terms. So this is natural log 3y plus 2, well, minus natural log 4, minus bringing down the 1/3. So minus, bring down the 1/3, 1/3, natural log y. All right, and that's expanding our expressions. And example number 8, we're going to condense them. So now we've got multiple logs, and we're going to squish them back together and make them one log. So first thing we want to do when we're condensing is move our exponents back up into the exponent spots. This is really log base 3 of x to the 4th minus log base 3 of x plus 6 to the 1/3 power. Once we've got our exponents up where they belong, now I've got a subtraction problem, which means when I write it as one log, I'm going to divide these arguments. So this is log base 3 of x to the 4th over x plus 6 to the 1/3 is the cube root of x plus 6. Answer for that one. For b, again, first start by moving the exponent back up to the exponent spot. This time we are adding our logs, so our arguments are going to be multiplied together. So this is the natural log of x cubed times x minus 4 to the 6. Can you leave the x cubed back here? You betcha. We just typically put the monomial, the guy that doesn't have addition in it, with the binomial that has 2 terms. So usually the monomial goes in front of the binomial, but either way will work. All right, for the u tries, I've got log base 2 of x plus 1 to the negative 5 power Moving that 3 up, I've got log base 2 of 6x cubed. All right, because they're being added here, that means I've got log base 2 of x plus 1 to the negative 5 power times 6x cubed. Well, this guy's got a negative exponent, which means I'm going to put it actually underneath. So that's log base 2. I need to make my exponents positive before I'm done. So x plus 1 to the positive 5 power. 8 goes to the bottom of the fraction because of that negative sign. The 6x cubed stays in the numerator because it is positive. 6 times 6 is 36 times 6 is 216. So 6 cubed is 216 x cubed. For b, I'm going to deal with these two first. So the natural log minus this natural log, I guess the very first thing I need to do is deal with this power. So this is really natural log of 3x plus 5 minus natural log of x to the 4th minus natural log of x minus 1. Now we're going to deal with the first two terms. It is a negative in there. It's a subtraction, so it's going to become a fraction. So 3x plus 5 over x to the 4th minus the natural log of x minus 1. And again, now I've got two natural logs. When I combine them, because of that subtraction problem, this is going to be another fraction. So this would be the natural log of 3x plus 5 over x to the 4th divided by x minus 1. If I see, that's x to the 4th. All right, and then that means I've got the natural log of 3x plus 5 over x to the 4th times, because we're dividing by this guy here, we're going to multiply it by the reciprocal of this guy, which is 1 over x minus 1. There we go. And so that's the natural log of 3x plus 5 over x to the 4th times x minus 1. All right, and example number 9 is change of base formula. So sometimes we want to go from one base to another, and when we do that, we do log of base b of x is equal to log base a of x over log base a of b, which sounds weird, but say I wanted to change log base 3 into log base 10. Then I would do log 10 of 5. Remember, we don't write the 10 there. This is common log of 5 over common log of 3. And this is what we put into our calculator. And flipping over my notes, that gives us not an equal sign, Miss Harris, and approximately 1.47. Is that the same thing as when you put this guy into your calculator? Absolutely. So what kind of question might you see on like an SAT or a PSAT, ACT would be, how would you evaluate this guy in terms of log base 10? And you'd have to show the change of base formula of this. So if I have log base 1/2 of 6 and say I want to go to natural logs, that would be natural log of 6 over natural log of 1/2. And you can choose any base logs that you want to. This is supposed to say evaluate each expression. I've copied and pasted incorrectly here. So I'm just going to do common logs. Common log 4212 over log 78. I guess it'd be helpful if I told you what that value was. This is negative 2.58. This guy here is 1.916. This would be log 33 over log 15. Again, choose whichever base you want to, unless it tells you specifically. And finally, this would be log 10 over log 1/3. And that is approximately negative 2.096. And that's it for section 3.3. Coming up next, section 3.4, we're going to start solving some exponential and logarithmic equations.